on the particular OS and then hardware. And then we do have some security related issue and then complexity as well. So some application need internet based. We are dependent on internet based. To overcome this, actually, we have onboarded into the Java technology, which will resolve the problems mostly. As we know, Java virtual machine is a key feature. And then second thing, in that virtual machine, if you see, there is an automatic memory management. So on top of that, actually, we do have a built-in security features. And then Java, everyone knows very well, that is object-oriented programming language, which we say object-oriented design. Let me get into that platform independent. So which will be write once, run anywhere. It will be converted to the bytecode and then it will run in the any machines which will run based on the JVM. Everybody knows the basic. So I am directly onboarding to the next level Java 8 feature. So why we are using Java 8? So what is the reason it is introduced? If you see up to Java 7, so the Java code is very lengthy and then so number of loops or collection processing, if we see, that is huge. Uh, very, very lengthy program we have written. And then if you see, we have to write parallel programming with a complex multiple threads needs to be created, and then it will be occupying, it will be confusions, it is creating a confusion. So those kind of problems overcome by Java 8. So and then one more thing, actually, we are having exception, handling null pointer exception or runtime exception. So these are all things we have to go with a functional programming concept to solve all these problems. So without breaking existing whatever codes available in the Java. So that is a major part. Java 8 is introduced. So So let me list down all the topics which we are covering today in this session. So majorly, if you see Lambda expression, function interface, stream API, method reference, default methods, optional class, new date and time API, for each method, and then final things is one parallel stream. So these are all the topics we are going to cover today. So if we talk about first topic, lambda expression, which will help to pass behavior logic. Let's say here we can say pass a logic. Java forced us to write anonymous classes. It is making code hard to read actually. For example, if you see in the earlier versions, let me create an example and then show here. If we see, for example, lambda tutor, writing in earlier system, how it was coded, for example. If you see, for example, in that collection level, I'm applying some sorting mechanism. Okay. So in that earlier system, how it was built actually, so we have to pass our list. For example, I can create a list. So in this list, we have to pass all the comparators. We have to create like a comparator and then what kind of input we are consuming. For example, let's say I'm using integer. For simplified understanding, I'm creating an integer. So what it will happen? So x1, x2, which will be compared each and every time. And then, so it has a many methods. So what it will happen inside that? So we have to write a logic for that. So what logic we have to write? For example, a minus b. For example, I'm considering a and then b. Okay, if you write like this, it will be sorted. And then we can get that output for that. For simplifying this actually, Java 8 introduced straightforward methods via lambda expression, which is the base of functional interface, we can say. Lambda expression allow function as a value. So what it will happen instead of that, simplifying this actually, so there is a parameter implies expression, what kind of expression we are going to do. So for example, I am using this strings list over here and then taking in. So input parameters, no need to declare any type and then you can directly pass this. This is a major feature of Java 8 in the Lambda section if you see. So it will be automatically sorting that inside elements from the given array. So for example, earlier I have written as in string list. Now I have converted to the integer list. Quickly, we have to finish it. That's why I have changed to integer list. How it is sorting, we can easily convert it and then see. So in the earlier system, for example, if you see, I'm using Java 8 feature like an for each still. So I can print it over here. If I run this actually, you can get the sorted list easily. So same thing actually. So this is a lengthy code. If you see in the Java 8, by default, they are providing this functional interface to achieve the lambda expression. For example, this is parameters. Along with that, you can go ahead with the expression. So what expression you have to implement, that you are directly getting it. So same line, if you see, this will be completed within 2 lines. If you see over here. So for example, I'm commenting out this line. Let's run this. See, this is simplified. That is a major feature of lambda expression over here in our Java 8 feature. So next topic, let me move on to the next topic. So whatever we have written still or learned still now actually, for example, lambda expression. So how it will be introduced in our system. So some of the system function interface already available. So we have studied or we have experienced earlier coding. So for example, how that function will help, predicate will help, consumer will help, as well as supplier. So these are all things predefined functional interface. Let me come to that functional interface topic. So what is about that core? An interface with only one abstract method, but we are majorly calling as a functional interface. So let me write an example for that. So functional interface data. Let me write it as this one. So here, how we can write it? We have to mention or it is optional. So we can write an functional interface annotation or we can leave it. So for example, interface I can say. So only one method I can go ahead. For example, I'm going ahead with the display. Okay, this is a functional interface. Majorly, it allowed to display some data. So this is simplified. So if I say functional interface, let me get into that implementation. If I implement this method, so an interface which is having a same thing lambda expression, how it will be going ahead. So I'm simply passing an argument. That's it. I'm not doing anything. So next thing, if you see, I can call that abstract method. The magic here is actually earlier we have to write, we have to consume, we have to do many things while writing the display methods. So it has to implement. That's why we are falling into that function interface concept. So the lambda expression must have a target type, which is a function interface, we will say. So here, if you see, this is a target type is string. So same way, if you see in that earlier logic, there is an expression is there. Some result, a minus b, comparison results is there. So that's why we are majorly using that function interface. Let me give some more example. Majorly, we will use in our Java 8 feature. So some more predefined, let me tell you. So for example, predicate is there. So this is majorly used to validate our result or we have to process something from the given input. For example, is even is there. For example, whether given number is even or not. So here what you have to do, so we have to test it. We have to give some inputs and then we have to test it. Then only whether that number is even or not, we can find it out same way. So there is a test function is the major role player here in the predicate level. So next level, if you see in the Stream API level, we can say, so if you see in that function, so in that function, we have to give what kind of input and then what kind of output, how we are processing that input output here. So here what it will happen, whatever we are given. So here whatever we are given, for example, I have a 10. Whether that 10 needs to be transformed or we have to process somewhere, we have to simplify that number. For example, mod divided by 2. What will be the output? We have to apply and see. Same way, if you see, next one is an consumer. Everyone knows about the consumer part. So consumer also having an some logic. How that consumer will be consumed from this lambda expression, we can say. What kind of input I am accepting. So this is the accept method is a major method. So what I have to input, for example, if I wanted to do something, so that number I can print it. So for example, I will say Java and React tutor some number I wanted to accept. If you run this accept, it will accept that input and then it will print. That's it. So if you see next level, there is a supplier is a predefined one. Whatever you are giving that input, it will consume from the supply. If you see in the consumer level, and then supplier will allow to get it here. So I am putting all the sys out here so that you can understand that output. This is the core part of predefined functional interface, I will say. So everyone should know, definitely. Most of the people will know that about Java, but they will not know about these features. So majorly these features are these predefined function are utilized in the stream level. So this will not accept it. Sorry. Yeah. So whatever, it will be printed over here directly when I accept some input. So let me run this program. See, first one is an hello world, which is I am created a custom function interface, which is directly displaying. I haven't written anything, but I have processed the expression. Expression means which is system.out.println. So next one, if you see, so the predicate, so whether it is an even or odd, we have to predicate, right? So final output we are giving as an true or false. So the given number, for example, if I'm giving 11, so what it will happen? It will go false. This is not a even number. So this will go false. So next level, I'm talking about the function. Function having an number and then it will process it and then give up output as well. So this accept will not give, but in function we will apply that number and then we will be giving that result over here. So if I pass, here. So here, what is the remainder? Is it different? So if you see I mod 2, what is the remainder? It will be applied and then it will give that remainder. So next one is a consumer. So I can consume some inputs from the user and then I can process my output. For example, here I have passed accepting as an 10 values and then it is inner level, it is printing that Java and React Router 10. And then if you see supplier, if I am giving some input, so that is consumed and then it will be allowed to get it. That is the major part supplier will play over here. Yeah, this is the major examples I can say in this functional interface topic. So let me get into that next feature. Major feature in Java 8 is a stream API. So stream means earlier actually we are processing all list of items in the collections. For example, list, hash map, array list, so vector, hash map, hash list, hash table. So all those things we are using. So from that collection, we have to process it. Some data we have to do, we have to transform or we have to do some operations. So those operations, if you see, that will be simplified here. For example, that stream will be allowed over here. The stream, what it will happen? So inside that, it will process all the values and then it will transform in pipeline manner. So let's come to the theoretical part. A stream is not a data structure. So it processes the data from the collection in a pipeline manner. It will take it as a sequential order, they will say. So unsequential, if I wanted to take it in, I can go the parallel stream. So by default, sequential way, if I wanted to process, it will be going to the direct stream API. So why we are using the streams? There is no loops over here. We no need to write long and long, big size loops or multiple loops. We no need to write it. And then if you see declarative coding, we can say. And then if you see major feature like an every application having an major features like for example filtering, mapping, sorting, those functionality it is introduced in the stream level APIs. And then along with that, as I mentioned, so parallel execution is allowed here. So via parallel stream. So how that stream will flow here? So there is an operations are there. How internally it will be operating all those collection values and then how it is giving the output or how it is consuming that inputs we can say. The whatever comes from the source as a collection. So from that collection there is an operations are there. For example, intermediate and the terminal. Intermediate means all the operation. For example, sorting, filter, map, all those things it will come. Terminal means how we are taking that output or how we are iterating that for each, how we have to collect it from the source, how we have to change the format and then we have to collect it. For example, collect we will say, collect two list we can say. And then we can say one more layer is the short circuit action. Here is the short circuit operation, sorry. So these are all the flows. The stream is processing the data from the collection. We can say streams are lazy. So operation executed only at terminal state. So that's why we can say streams are lazy. We can say. I will bring some examples over here. So let me get into that stream API to type. I have one list actually. List is an interface as we know. I'm doing some array list assignment. So I'm writing same way, sorting concept or filtering we can go. First, I will go with that sorting concept. So I have written over here, and then in the middle, I have written some numbers. So this integer list need to be converted to stream. So converted to stream, and then I have to sort it. So that is a function for sort it. And then, as I mentioned, terminal operation is there. So if I wanted to collect, I can collect it. So how I wanted to collect it. So collectors dot, I can say tool list. I can say I'm collecting as a tool list. So here I have to return list, same list. I have to do it. And then output list, I can say. So this output, we can run it in the loop, or as I mentioned, direct collection also allowed. Here, for each loop also, by default, functionality is available in the Java 8 major feature, I can say. So if I run this, oh sorry, string, it is collecting. So let me write it directly to collection. So collector will come back. So here directly we can go ahead with that system dot out dot method reference. This also major feature here. So as part of this Java 8 feature. Array, 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 array. So one thing I have to correct here, I have received as an string list. That's why that collector is not working. So now I'm moving back to that collector.to list. I'm printing over here. Yeah, this will be printed like this. So integer, how it is sorted, and then we are collecting as a list. As I mentioned earlier, how we are collecting here is this is a terminal operation. Whenever that collect is executed, all the sorting will happen, and then it will be returned to that result. That is a lazy, we can say. That is a concept majorly we can say over here. So it's about Stream API. And then let me get into that next feature. A method reference. So method reference, as I mentioned already, let me create a new class for method reference. Method reference. So what it will do actually. So lambda expression, as we mentioned, still we have to optimize it. So some kind of single level input, we have to optimize it. So for example, what it will happen, as I mentioned, let me get into that Stream API example. Here, if we see here, so we have optimized. This is method reference already utilized. So how we have to process it means, so earlier, for example, we have to process it like this. We have to print this result as we see in the consumer part, how it is consumed over here and then how it will be printed over here. So like this input, we have to simplify this, right? So that's why they have introduced method reference since. So this will be shortened. So we have to directly process that output. Any kind of input, we can process it here via system.out.println. So that's why majorly this method reference is introduced. If you see in the method reference, actually, three types of method reference is allowed over here, majorly to shorthand this actually. So static method reference is there, instance method reference is there, and then one more thing, constructor reference is there. So static method means if I'm creating some static methods, so let me create a method over here. So whatever available in the class methods, we can directly access via the static method only. For example, I am doing display. This is static method. So whenever I'm going to that static method call, I'm using inside class, but let me get into that access class. So let me move the spot into that another Twitter class. So here, so this is the method referring for access Twitter. So I have created. So I wanted to access that static here directly. So whenever I'm printing, I no need to pass anything or no need to process inputs. So directly it will be passed to that direct method. So for that, how they are introduced actually, for example, in the sysout, I am putting. So in this, if I do display here, we can pass that input also. For example, in that list I have shown, right, in the Stream API level. So we can pause input also, but still I can directly access it via, this is static method reference, we can say. I think this is directly consumed. Let me get to that some other example. So for example, let me assign it to some runnable. Okay, here. So for example, in that method reference access tutor display. So as we know, this runnable will be allowed. For example, I will creating here directly it will be allowed. So to print the results like this, it will be allowed. If I run this actually directly, I can call this run method. So it will be allowed to print the result. But if you see here, static method reference, what it will be doing over here, it will be directly having an access. Here, if you see, if you run this, it will allow to call this static method. See, I will change this name, predefined. See, this is static method reference. Here, I will pause the session 10 minutes, take a break, and then you can come back, guys. Welcome back, guys. So I will close end up this section. We already running out of time. So I will end up this session after completing this method reference. We can have a short session for the remaining topics, or I will cover little bit and then we will explain the example in the next session, definitely. So, and then now I'm getting into that. Let me get into that. So for example, I'm writing some area called, sorry, some value welcome. I'm writing. Okay. So I'm commenting out. And then whenever object instance type, if you see, so we have to create an object. For example, here we have to create a reference and then we have to go ahead for the display method. We have to call it here, but I can directly again assign it with the runnable 3. So here you have directly use that class. Instead of that, you can go ahead with, so welcome. So you can run this. Same way, you can run this method. So I will commenting out this one for your reference. I will share this code for your reference purpose definitely. Let me run this. See, this is returning the data. So that's why we can take it from there. So for example, if you want to process some data, you can directly put it into the sysout. So here what I will do, same way. So I don't want to confuse from this level. If you see, this reference will be utilized as a string. So method reference, it will be allowed from the instance method via also. 1 second. So, so let me change this program so I don't want to confuse. So same thing, I'm going ahead with that sysout. So I will give the example for that implementation also. Same way, if you see, I don't want to confuse here. See, this method will be called over here. See here, if I assign directly without returning, so I have return. So return also, it should be an format of string. We can return it. And now this will be running to the instance method. So one more is there actually. So there is a method called actually arbitrary objects. So arbitrary, this I can say static method reference, and then this is instance of object method reference, I can say. And then next one is an or inarbitrary. For example, predefined some of the interfaces will be available. Those interfaces directly created and then assign it to the objects. For example, I will write an example here. Let me write an interface over here. Interface, display interface I'm creating. Okay, this contains some messages. For example, I can say, so message is like in here class. This method will return the type of message. Let me create a class for message. And then in that, so in arbitrary I mentioned, right? So integer class also we can try integer dot new, but still I will create an example and then I will show it here. So this is message Twitter, we can say. So here what we have to do for the in arbitrary type of method reference. So here what it will happen, so if I wanted to create some message, okay, so this message type or let's consider, so this interface, I can directly assign it an interface. What it will happen, so here there is a new type for that. So instead of that, I have to create a class directly as a new. So here directly we can go ahead that message type class with a new. So this object will be created. This will be taking care of that sysout here. So whenever I call that get message, for example, from this interface, it will be printed. So let me comment out this section also. So here what it will happen when I run this, see, we can get that. This is in arbitrary type of that. So maybe if you want to use integer type also, integer data new, we can go ahead. So this is also allowed. But this return type should be integer, that we have to convert it. So that is major part of this method reference. So that's pretty much about the method reference. So let me quickly go through, or let me quickly tell about the next session topics. Default methods, which is introduced in the Java 8 major feature. So, adding a method to the interface breaks all the implementation classes. So if I wanted to write something inside that our interface, so that should be meaningful, and then it should not affect all the implement class. So that's why they have introduced a default method. So default method will allow method implementation inside our interface. So earlier we do have inside the abstract method, abstract classes only. So instead of that, in Java 8 onwards, they are allowing implementation inside the default, inside the interface as a default method, which will be allowed. So why they are allowing here is actually there is a major feature every application requires backward compatibility. So this kind of default methods will be allowed to backward compatibility. And then one more feature, classes can override default methods as well. So that is one major feature. And the next one is an optional class we will be saying. So optional class, actually why they are introduced, whenever we write, or whenever we consume some strings, or some values we are trying to occur from the null object, it will throw an null pointer exception. That's why this optional class, what it will help actually, it will check that validation. So there is an methods called off nullable is there as a static method. So it will prevent unexpected null access. That is a major part. If it is null, we can return some default value. For example, if the user is giving some account, that account is closed already. So whether that account is available or not, we don't know. So whenever they are trying to access that account, that is a null account, we can say typically. So here, if it is not available, we have to return some valid errors, right? So that kind of situation, this optional will be helpful. And then it is having an some important methods, for example or else throw, whether the account is present, like that mechanism is there to help over the Java 8 features. And the next one I can say new date and time API. So those date and time API will help. Actually, it is an concept of earlier one is immutable. That is not a thread safe actually. So if I am using inside the threads, it is not safe. That's why we have moved to this new date and time API. So this is having an immutable and then thread safe mechanism. And then we do have a clear class names. For example, local date, local time, those classes are available. And then zoned date time, and then local date time. So these kind of important classes we have introduced. Next important feature is an for each. So for each, as I mentioned, we already seen actually. So there is an internal iteration. It will take an input and then it will process it from the source system. So that is a major part. So it is clear than for loop. We have to for loop write and separate loops. Actually, we have to process. It will avoid. It will simplify that lines also. It will number of lines will be decreased and then clear whenever that programmer codes. And then if you see next level, actually it is utilizing multiple core processor automatically. For example, parallel stream, if I don't want to go with a sequential manner inside the process, so I can go ahead for the parallel stream. In that kind of situation, the multi-core processor features also, it will be applicable here. So whenever comes that we know, right, collection having a large data set means that will be processed over here in the for each. So and then CPU intensive task we will be saying. So it will be optimizing from the parallel stream level. We can include that data list. Let's say collections. We can say that's pretty much about the today's session. So now we can go get into that questionnaire session. Everyone can ask their doubts. So hope everyone understand and then clear picture about now Java 8 feature. So why I am taking this Java 8 feature as an basic level initially. The reason actually we have to understand Java 8 feature. Then only we can get into that Java 11, 13, 17, and then 21 and then 25 features. So that's about the Java 8 feature. We can go out for the questionnaire session. So I'm ending up this session right now from the tutorial level. Thank you everyone for spending a long time with me. That's about me. Thank you all.